All right, I'm back. The last week was a little bit too busy, a lot of deadlines, and anyway, hopefully this week returning back to normal schedule. So today I'm going to try to solve one coding problem as usual under 40 minutes or so. This stream is for entertainment purposes only, and let me quickly check that everything is up and running. Actually. Yeah, looks like that. All right, so without further ado, let's jump right in and see what's the problem we've got today. Pick one. Easy problem. All right, sounds like we're gonna make it. Given an integer in base 10 and a base k, return the sum of the digits of n after converting n from base 10 to base k. Return the sum of the digits of n after converting n from base 10 to base k. After converting, each digit should be interpreted as a base 10 number, and the sum should be returned in base 10. Like moving from, let's say, decimals to binary and stuff like that, right? Number and the sum. After converting, each digit should be interpreted as a base 10 number, and the sum should be returned in base 10. So 34, it's 6, right? So we know that 5 times 6 is 30, plus 4 is 34, so the sum is 9. I see. All right. So constraints n from 1 to 10 and k from 2 to 10. So, all right. Let me see. So let me quickly switch to the whiteboard to just showcase what I'm going to do. So the problem itself is kind of straightforward. So what I'm trying to understand is what data structure to use, so to speak. So we know that 2 is the minimum, right? So should I use the array to track number, what's the integer in every base order? Let me explain what I mean. So let's imagine we have number, I don't know, 15, right? And we want, so this is in base 10, and we want to convert it to the base 2. All right. So, wait a second. Isn't it way simpler? So we don't need, actually we can get the number for whatever, let's say this example of 34, right? So we have this 34, so we're moving it to 6. So percent 6 is what? It's 4, right? Alright, so we already know that the last digit is 4. Now we say 34% 6 squared, right? Yeah, it doesn't work that way. So it remains 34. So if we subtract 4, it will be 30. So we need to divide it by 6. So that's what we need, right? We don't need the reminder, we need this thing. So okay. So n is up to 100, right? So 2 to the power of what? So 2 to the power of 7 is 128, right? Because 2 to the 4 is 30. No, 2 to the 4 is 16. 2 to the 5 is 34. To the 6 64. 2 to the 7 is 128. So it's more than enough to support 100. All right. So all right. And position, right? It starts with 7. And actually we can have u integer or whatever. Let's use int for now. So we can say the largest as, or actually as 2 to the power of 7 is greater than 100, right? To satisfy, and which satisfies limits. Right, we have it. Right. So what we're going to do, we're just going to divide this number by something. And obviously this number should be less than whatever is there. And the last one will be the remainder overall, right? So the last one will be just the remainder of the base there. And this is our sum, right? in sum equals 0. So we don't need any structure at all. It's like constant time and constant space. Constant time because the position itself is, well, yeah, it will be logarithmically dependent, right? Because if it's 1000, then we need 10 here, so it's not 70. Whatever. All right, let's go. So while while position is greater than 0, all right, we say this sum plus equal and divided by power k to position, right? And then here we say sum plus equal position percent, oh, not position, sorry, and reminder k. And here we say position minus 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 minus. So let's see how that algorithm gonna work in the case of example 1. So we start with 34, right? Divided by 6 to the power of 7. So this is obviously larger than this, so it will be 0. 34, so until we get to 6 to the power of 1, which is just 6. Sorry, 34. Right. 34. So it will be 5, right? And then once it goes to 0, then whatever base is 0 degree is 1, so anything divided by 1 is the same number, so we don't need it. But what we need the final one will be just the remainder, right? So the final one will be 34% 6, which is 4. So the overall sum will be, so all zeros here, the 9, right? So this is how it works. So we checked the code, and now let's just return the position, sorry, the sum. So this is super simple code, and what we need is just to run the code, right? That's all we need. All right, let's see if it works. All right. Let's see if it passes all the checks or we missed something. We missed something. (42) in binary. should we subtract from n this number? I think yes, that's right. int let's say so we have nk, let's say m is this guy, right? We add it here, and then n is minus equal m. Right. I think that's what we're missing. Actually, oh, I need to add actually here is just key. Because this will be our reminder. And then I don't need to instantiate it every time here. You can just assign it here. Right. And then update it here. No. Then. All right. So n minus equal m. No. So it was correct. So let me see then what's the issue, why it doesn't pass in this binary case, which is interesting, right? Oh, it says 32. All right, let's see out position pause num equal what? Equal this thing, right? Yeah, it's kind of fun. Maybe I will not solve it today. But that's okay. Run the code. Let's see what we've got. Why it's this? I wonder. It should be zeros all the way, but yet it is not. Actually, it's I mean, I don't necessarily need to start. I can start with position 2 less than 8, right? And all I need to say is just this, right? So now I add the position and do k times equal k, right? I mean, what's exactly the point of using the power here. So run the code and see. Ooh. Let's see if k greater than n, right? If k is greater than n, then break. Doesn't make sense. And else increment k. Let's see. Should be very easy. No. Why is this? So position 2, num 5. Ah, I see. Because we add entire 34. I see. Alright, so let's say int kk equal k, right? So we'll use kk here. Kk. Or actually, I see, yeah. We times k because kk is larger and larger every time. It's just to remove the power here, right? So now it should work. Let's submit and see what was the issue with this binary thing. All right. So position 2, we have 21. 2. We basically divide by 2 at the position 2, right? We divide by 2, and obviously we get 21. Then in position 3 we get 1, 0. Yeah, so we're doing some nonsense here. All right, so let's switch to the whiteboard. So how much time do we have? We have roughly 20 minutes, so hopefully we will pass all of the checks today. So we have 42, right? So at 32, so it's 2 to the power of 5. So it's 1. Then 32 plus 8, so we skip 16. So it's 40, and then it's 2, which means the last one is 0, then it's 1, and 0, right? So 1, 2, 4, 8, 16, 32. All right, so it's 3 digits, right? So, but how do we So if it's 1, 2, 3, 4, 5, 6. So so at position 6 we have 1. At position 5 we have 0. At position 4 we have 5. Then again, even. Ah, I see. Then 2, 21, and obviously, wow, the last one is what we need. All right. All right. So it's basically this thing. All right. That's what do here. Ta-da! And we even haven't closed this thing. Also, we may try to use unsigned integer at here, because why not? It's just the counter. We don't really care. And yeah, it's just the counter, so we can start with 0 and then it will be 6. Doesn't really matter. So the sum, and then k is k, obviously. And alright, that's it. Nothing else to really improve. Let's submit few more. Oh, I forgot to switch defaults in. Alright, so this is the final version of it. Well, that's what we missed, this reminder of the base. So submit few more times. Alright, so we get the best one so far, 0 and 5.7. Let's see if we can get these two together. Interesting. We should be able to. So we see out it was faster than without see out. 6 megabytes, it was 5.7. Oh my goodness. Can I get 2 please? 5.7 and 0. Slightly better. Keep pushing. No. Huh, but we're already like, we're already better. Come on, you can do it. No. Alright, now the worst in terms of time and space. Jesus, why it's so hard? Just give me best time and space possible. Oh no. This is embarrassing. Of course you cannot. Alright, I agree for 0 here and 60 something percent here. No way, are you kidding me? You gave me 5.7 here. 5.8, so the first one was the miles better than whatever follows. Come on, just time and slightly better in terms of memory. We can get to 70 points or so. Actually even to 90. Yes! Best of the best. 0, 5.7 seconds. So let's stop here with these numbers. So 195 points. Not too shabby for the return, although it was an easy problem. Anyway, it's good to start with good numbers. So 100 for the time. And space complexity is 95. So total is 195. Let's stop for today. Thank you.